Good afternoon, everybody. Hopefully you can hear me, and I'd like you to welcome you to this webinar on lighting up the London 2012 Olympic Games. My name is Mike Simpson, and I'm the Technical and Design Director for Philips Lighting here in the UK. So welcome to everybody, wherever you might be around the world. I'd like to start by taking you back to a date that was quite significant for us. This was the 6th of July 2005, and the place that I'm going to show you is the middle of London in Trafalgar Square.
The International Olympic Committee has the honor of announcing that the Games of the 30th Olympiad
became a reality for us once we'd officially heard that we had won the games. So where did we go from there? Well, there were some underlying principles that we were going to use for the London Olympics. The first of those was sustainability. We wanted these to be the most sustainable games that had ever been put on. But we were concerned that we didn't want the venues to become white elephants and left unused after the games. So a lot of attention was given to how the venues were constructed, how they would be used in the future after the games, and of course how we could build the whole of the Olympic infrastructure with the minimal impact on the environment in terms of carbon, production, transportation, and all those other things. So for those of you that were watching the games, apart from the permanent venues, you'll have seen some other venues that maybe were related, you recognise from familiar London landmarks. So up here we have the Equestrian Centre, which was centred in Greenwich Park, which is where the Royal Observatory is, where the meridian for time is based. Over here we have the tennis at our well-known tennis centre at Wimbledon, where the championships take place. Down here we have the triathlon, which took place in the centre of London around many famous landmarks, including Buckingham Palace. And then over here we have the beach volleyball, a new event for the Games, where we built a beach in the middle of Horse Guards Parade. So we tried to use many of the existing London landmarks rather than build a lot of new venues. The other thing that we wanted it to be was something that would be truly spectacular and people would remember as the Games from London. So we hope that with the show that we put on, that was what you saw. However, we were faced with quite a unique challenge. The site that was chosen for the Olympic Park was an industrial wasteland to the east of London, and the challenge was to transform this into an Olympic Park in just 7 years. On this wasteland we had something like 2 million tonnes of soil that needed to be cleaned and recycled, and over 80% of that was put back onto the Olympic Park. The site also contained Europe's largest fridge mountain, which you can see in the picture there. Also on the park there were many canals that again had fallen into disrepair. They needed to be cleaned up, and all the power lines that you can see in the picture had to be buried underground before the first building could get underway. So all of that was transformed into our Olympic Park, which is a 246 hectare site to the east of London, and you can see there the stadium in the foreground. So those were the challenges. It was all about sustainability, it was about legacy, it was about creating a spectacle, and it was trying to do it all for within a budget, of course, and keeping the whole legacy of the games in mind. So why is legacy important to us? Well, if you think about the impact on the environment, on transport and everything else concerned with the preparation of the games, and then the actual games themselves, which were over an 8-week period in the middle of the summer, that's only a very small part of the whole lifetime of the project. You know, we would expect the park to be there for 100 years and the buildings to be there for at least 50 years. So thinking about the legacy and what was going to be left at the end of the Olympics was very important as part of the design principles that were involved in putting the project together. If we look at the main permanent venues on the Olympic Park, you can see there the Aquatic, Eton Manor, which is where many of the warm-ups took place, and also some of the Paralympics, the Handball Centre, the Media Centre, the Stadium, and the Velodrome. What those charts are showing you is, in terms of the design of the buildings and their overall carbon usage, how they related to our best practice design guides at the time at which they were conceived, which was back in 2006, 2007. So you can see for the Aquatic Centre, it was already 15% better than our best practice at the time of being designed, and the Velodrome was something like 32% better than the best practice for a similar building of its type at the time that it was built. So from the very beginning, in terms of the design and construction, minimising energy use in the buildings was an absolute paramount importance and one of the main design considerations. Also within the Olympic Park, it had its own power generation. And again, this was using conventional power generation techniques, but we also had biomass boilers, we had central chillers, and some of the waste heat that was generated on these power stations was fed back into the venues, reducing, in particular, some of the heating load and also a little bit of the chilling load by something like 20%. And there were 2 of these power centres on the whole of the park. There was also some renewable energy in the form of photovoltaic. So the media centre, which you see in the top picture, is covered. The roof is covered with photovoltaic panels. The wind turbines there sitting on top of the lighting halos, which are part of the main concourse area, and some of the road lanterns you can see here have got photovoltaic panels mounted on the back of them. Now they don't provide all the power, but they make a contribution to the overall power consumption of the whole site and of the lighting. So what about broadcasting, which of course is where most people were watching and were able to engage with the games? The television viewing figures for this Olympic reached 4.8 billion people globally and across more countries than ever before. If we compare the number of broadcast hours in London to Beijing, you can see in Beijing it was 61,000 total broadcast hours, and in London that went up to 100,000 broadcast hours. And it's estimated that in the UK over 88% of the population watched the games. All of the broadcast was in high definition television, and in addition to that there were 200 hours of 3D television covering the main events such as the opening ceremony, the final of the men's 100 metres and the 5,000 metres. So the principal events were all covered in high definition television. So you can see how important broadcasting was to the whole of the games. Now we've got a little poll here just for a little bit of fun. If you take the last 2 years, so the Winter Olympics and the Summer Olympics, perhaps you'd like to just click on the buttons on the side there and have a guess as to what the television income that was generated for the International Olympic Committee from those 2 events. So that's from the Winter Games and from the Summer Games. So we'll just give you 30 seconds or so to click on one of those. Just coming up now. If you haven't had your guess, place your bets now. And that's the end of the poll. I have to ask the moderator, do we see the results of the poll at this time? Okay, so it looks like we have a majority of people, 36% voting for C. Well, in fact, the answer, let me just move back to my next slide. It's not coming up. In fact, the answer is C. Is B. It was $3.8 billion was the income for the broadcast rights. So an enormous amount of money, and you can see why broadcasting and of course getting the lighting right for broadcasting is absolutely important. So in terms of lighting, the broadcast requirements for London were pretty much set along the same lines as we used in Beijing and in Athens. And in fact, for many of the venues, the broadcast requirements for Beijing in particular were virtually copied across and taken into our venues. So that means for the light source, our colour temperature was 5,600. That's to optimize the colour to match the requirements of the TV cameras. The colour rendering had to be above 80. So again, we're obviously talking about colour television. It's absolutely critical that the colour rendering is important. In terms of lighting levels, the horizontal illuminance is very much something that is required because it sets the camera f-stop. So that's the amount of light that's going into the camera lens. Some of the cameras that were being used had very long zooms, sort of 500 to 1 zoom, and you lost a lot of light in the camera. If you ask any of the broadcasters how much light they wanted, they would always say more than you could ever provide us. But at the end, we have to have some practical level of light. And the horizontal illuminance was principally set by the amount of vertical illuminance that we had. So if I just moved onto the vertical requirements, so again, these were typically for all the venues. The vertical requirement is obviously so that you can see the objects. We're interested in the light falling on the athletes as well as the light that falls onto the ground. It is what determines the quality of the TV pictures, and we have to make sure that we achieve the right vertical illuminance for every camera location. So for the Olympic Games, the average of all the vertical across the playing field areas was 2,000 lux, and the minimum, the value which it shouldn't fall below, was 1,400 lux. And to give you some idea of what that means in design terms, on the left-hand side, you can see the Olympic Stadium, and all the little dots are camera locations, particularly around the main field of play. Those are all things like steady cams that move around. They're not fixed position. The ones in the seating area are all fixed cameras. And on the left-hand side, you see the camera plot for the Velodrome. And in many of the venues, we're talking something like 50+ cameras in the overall design. So to achieve the vertical illuminance, it's very important to get the lighting in the right place. And this was, I think, something that was very much a theme that came out from a number of the venues. you can imagine that if your lighting is coming at too steep an angle, it's very difficult to achieve vertical illumination. Whereas if it comes in lower down, then you get a much better representation of the vertical. So you're much more able to achieve the vertical luminance. So actually achieving the right lighting requirements is as much down to the architects who design the buildings and place your lighting as it is down to the lighting designers and the lighting engineers. So if we just carry on with the other lighting parameters, for broadcast, the uniformity in the horizontal direction, we can either measure it as a ratio of min to max, or we can measure it as a ratio of minimum to average. And you see there the numbers that are required for both the horizontal and the vertical requirement. And again, if you talk to the broadcast people, the people who have to put the pictures out, they'll actually say that getting the uniformity right is more important than it is achieving the absolute lighting level. If the lighting level fell 100 or 200 lux below that 2000 average, it was much less critical than it was having a good uniformity, because for the cameras to try to keep in focus and keep the object so that it's visible as they move around, uniformity is very important. The next requirement was glare, and this is something that we have to take account for both the cameras and also for the athletes themselves. For the athletes, we have a thing called a glare rating, a GR, and for the events in London, the figure was 40, which was the maximum GR that was required in the designs. And although it doesn't specifically relate to what the camera sees, the broadcasters also like to have a low GR figure, because it's another factor, along with making sure the lights aren't at too low an angle, that helps to ensure they don't get glare and flare in the camera lens. And on the left-hand side, you can see one example. This was from some early positions of lighting in the Aquatic Centre, where the lighting in the diving area was mounted almost immediately behind the area where the divers were. And you can see in that picture somebody standing on the diving board. It's almost impossible to see the details because of the light coming from the floodlight in the background. So we have to take account of glare. Right, one of the things about the stadium, and I've got a slide here, but I don't know if the second image is going to appear, I'm afraid. But if you look at the image there, this was the very early image of the Olympic Stadium. You see in artist's impression and also in section. And this was what we all thought the stadium would look like until about 6 months into the build, when somebody said, you know, those floodlight paddles that we see in that picture look to be a bit lower than any of the stadiums that we saw in Beijing or Athens or Sydney. And when we looked at some of the numbers, they were mounted at something like 38 meters above the playing area. And if you look at the other Olympic stadiums, the lighting was mounted at least 55, 60 meters above the playing area. So you start to ask yourself some questions. You know, why is this so different to the previous stadium? When we started to do some calculations, we actually worked out that actually those floodlights were much too low and would have caused significant camera flare for the cameras, to the point that you couldn't guarantee that you'd get really good broadcast pictures from the stadium. Now, there's lots of reasons to change the design of the stadium, but when you're already 6 months into the build, they have to be pretty good reasons for the stadium to change. But you can see with the impact that the broadcasting has on the overall games, having lighting that was going to cause poor camera pictures was just not acceptable. So at that point, many people put their heads together, and in a fairly short space of time, the roof structure was redesigned, and the Olympic Stadium that we know and love now from the games was produced. Unfortunately, my animation isn't coming on, but I'm sure you're all familiar, perhaps, with how the stadium looked finally with its crown of floodlights on the top. Okay, so what else did we have to look at in terms of the broadcast requirements in London? Well, something that started to be noticed during the test events was the requirement for super slow motion recording. In Beijing, the super slow motion speed was 70 frames a second, and in London, the broadcasters had decided, without really passing the information on, that speed would be up to 300 frames a second. Now, at 70 frames a second, it doesn't make a lot of difference to your lighting, but at 300 frames a second, it does. If you look at what happens with a typical discharge lamp, it actually switches itself on and off 100 times a second, because as the mains frequency varies, in the UK it's 50 cycles, so we have on and off happening 100 times a second. If it was a 60 cycle supply, then that would be 120 times a second. So you actually get a flicker, but at normal frequency, at normal shutter speed, the camera can't pick it up, and certainly the human eye can't pick it up. But once you move up to 300 frames a second, then what happens is you get the camera picking up the light dark that you get with the shutter varying with the shutter speed. So the video image there isn't working at the moment. But let me show you this other sequence, which is a video image taken from the games themselves. So this was in the Velodrome, and on the left-hand side you'll see some video footage taken at a test event, and then on the right-hand side you'll see some video footage taken at the actual event. We just run this sequence. For some reason the cyclists just go backwards, and then on the left-hand side you start to see that flicker occurring. And this flicker is because the lamps are effectively switching on and off at 100 times a second, whereas on the right-hand side, at really super slow motion, you get absolutely no flicker at all. So this was an effect that was noticed in all of the venues, and ultimately was put right by introducing electronic control gear that ran the lamps at a much higher frequency, which meant that the flicker disappeared. So for the Velodrome it was solved there, and in the main stadium we tried to rephase many of the lights by switching them onto different phases, so that we got a better overlap of the lights from 3 different phases to try to even out the ripple. But one of the things that we've certainly learnt from the Olympics is that for future events where they're using super slow motion broadcasting, it's not enough to simply say you should try to avoid flicker. The flicker, to completely eliminate it, should be less than 2%. So if you take if you like, the difference between the top and the bottom, it should be no more than 2% of the total. So we've now got some very specific figures that we know that we have to try to meet, and we'll start to integrate these into our lighting guides and standards as we go forward. So another quick poll here: would you apply the same Olympic standards if you were designing a major sporting arena in your own country? So again, just a minute to answer that, yes or no. Okay, I see our time has frozen. Okay, that's interesting. So we can see there that most people would say yes. I think it's always interesting when people talk about lighting sports events. You know, what criteria they use, and certainly, obviously, if you've got an Olympic Games, you're going to go for the very top criteria. But I do know some people that will go in a sports hall, for example, and want the very highest lighting quality. And you go, well, actually, are you ever going to have an international championship in this venue? But that's interesting feedback. Okay, so let me tell you a little bit more about some of the venues. This was the final design for the London 2012 stadium. So here you can see it looked very different from that earlier image, with 14 triangular towers mounted on top of a ring beam. So the top of those towers was now something like 63 meters above the playing pitch. So plenty of height, so we were hopefully assured of getting very good broadcast pictures. For those that want to know exactly what happens, this is the aiming diagram. So in total there are 520 2-kilowatt floodlights in the stadium, and this shows, each of those lines shows where each of the floodlights are aimed. So if anyone's got an Olympic stadium they're planning to do, there's a little example of that, how it might look. And that aiming is designed to give you all those parameters that we talked about before: 2,000 lux average vertical, 1,400 lux minimum on the vertical. That produced just over 3,000 lux horizontal, if you want a reference figure. And the glare rating was 38, so below the 40 figure that was set as a maximum. So the first time that the floodlights appeared on site, here you see the masts. It was a snowy winter, but all the lighting was assembled onto the towers. And I have to say, I went up the top of these towers when they were on the ground, and already that seemed quite high before they'd even been put on top of the stadium. So at that point, everything was wired, installed, and tested before we came back something like a year later to see the masts in their final position. And each one of those masts weighed about 60 tonne, and they were hauled up complete with all the lighting and the control gear, and then they just had to finally be cabled up to make them work. When we came along to do the commissioning, in fact, as a working place, it was quite luxurious. Having more or less redesigned the top half of the stadium because of the lighting, we had a great input into how the work platforms were designed. So actually, it was quite an easy working space compared to some towers that you get. If you have a look at the mounting of the floodlights, you'll see there are two different types. These ones here with a extra black gearbox on the top are hot restrike, which means that in the event of a power failure, when the power comes back on again, the lights would come on straight away. And these ones are standard, which would have a delay period of something like 15 minutes before they come back on again. So half of them were hot restrike, half of them were ordinary, which meant that out of our 2,000 lux we had always a guarantee of 1,000 lux. To aim the floodlights, we use a small telescopic sight here that you can look through. That's clipped to the floodlight itself, and that is aimed at a series of points on the ground. For this particular venue, we used a GPS system to lay out the points. You can imagine how long it would take, if you're using a tape measure, to mark out 520 points on the ground. At each one of those points, we put a cone, and then the floodlights are aimed towards that cone. And for the whole of the project, so for the 14 towers and 520 floodlights, it took two teams working in parallel 3.5 days to aim all the floodlights, which certainly for us is a record, and that was very much due to the GPS system in helping us mark the pitch out. Once you've taken all the, once you've set all the floodlights, of course, you then go along at night to take your light readings. What they didn't tell us was that the pitch had an automatic watering system that came on at 11 o'clock. And indeed, one of our measurers, one of our lighting designers, was standing over one of those jets when it went off without warning. So these are just some of the things that you learn as you get involved with the venues. And then finally, we have the finished result of the lighting in the main stadium. If you move on to the Velodrome was a very different sort of building situated at the opposite end of the Olympic Park. For those of you that know the Pringle crisp, this is what it was nicknamed because the shape of the roof is a little bit like the Pringle. But it was a very unusual roof structure. The roof was constructed of a cable net, so that's a whole series of cables that are strung across the venue itself and then tensioned. And this meant that the weight limit on the roof was restricted. And so therefore we had to be very mindful of the amount of floodlighting weight, because that was the main weight that was going onto the roof. It also moved by about half a metre depending upon temperature and wind loading, and if there was likely to be snow or not on top of the structure itself. So for the people interested in arrows, this is the aiming diagram. You can see altogether 7 lines of lighting, of event lighting for the Velodrome itself, and the aiming positions relative to the track, and again some of the camera positions marked on that diagram. If we have a look inside, now this is not the London Velodrome, this is another Velodrome, and usually you get again a nice walkway that you can walk along to get access to the floodlights. In London, the floodlights were mounted directly onto the roof itself without any walkway, and so most of the aiming was set while they were down on the ground using protractors and verniers to get the right aiming position before they were then hauled up in the air, hopefully to leave us with the right aiming direction. This also shows you the other issue that we had with the London Velodrome. If you compare it to Beijing and indeed many other velodromes, the height of the floodlights off the track was really quite low. At the end there, the mounting positions of these floodlights down here, I'll just grab my arrow. So the mounting position of these floodlights is here, was something like 9 meters above the track, whereas in Beijing here, even the lowest floodlights were about 20 meters off the track surface. And this low mounting height meant that we had to be really critical and careful about glare towards cameras, glare towards the participants, and this was why, in the particular case of the flicker, we couldn't solve it by mixing phases. We had to solve it by installing electronic high-frequency gear to get over the flicker itself. The lighting levels that were designed in the Velodrome were, of course, the 2000 lux vertical towards the cameras. But you see here also a range of other lighting levels, and this is where the legacy element comes in, because the idea is that, of course, you won't always want to have all the lighting on for the broadcasting, but you'll be using it for local events. Schools will be going in there to do training, and so for that, 300 lux is more than sufficient. But because of the inaccessibility of the floodlights, there were 4 separate switching levels, each one of which would give you 300 lux, but none of which used any of the lamps in the other switching sequence. So it's a way of extending the lamp life, which has nothing to do with the requirements of the Olympics. It was very much to do with the requirements of the venue after the games were over for its legacy use. Taking measurements in a velodrome is also interesting. If anyone's never been into a velodrome, the very steepest part of the track is about 48 degrees, and the only way of getting up there with your light meters is either to take the horizontal readings or as you see on the right-hand side, one of our designers trying to take vertical readings balanced off a ladder. It requires quite some acrobatics. Another interesting fact was that we tried to get some drawings of the track itself from the person who designed the track. All this guy does is, for a living, is design velodrome tracks. And he said, no, he said, the design is a secret, but I can tell you that this track will take several milliseconds off the world record for cycling. And I think the games themselves prove that. So finally, we have the finished installation of the velodrome itself, with all the lighting in place, providing what was exceptional quality pictures for the broadcasters. So I now have another poll for you, just to keep you engaged. And this is the question: really, is do architects always engage with lighting designers at the early stages of a project? I think I've shown that in the case of the main stadium, having architects engage with you in the design is absolutely critical. And maybe for the velodrome, some of the lighting issues that had to be solved were very much a function of the roof height. So it'd be interesting to have your experience back on how much architects and other people outside of the lighting profession engage with you at an early stage of the design. We'll just wait for the result of the poll. Oh, well, that's good. Sometimes it's better than never. But of course, it would be much nicer if we had everything in the always column. Okay, so let me move on towards the end of the webinar now. The last venue really I was going to explain about was the London Aquatic Centre, a beautifully designed building by architect Zaha Hadid, but to increase the seating capacity for the Olympics, it had these two wings, one here and one here, which were added to the venue itself. And this increased the capacity up to about 18,000. And even then they didn't have enough seats. So the lighting inside, again, this was very much driven by the architect. The lighting was within pods or holes within the roof structure. None of the lighting was to be protruding below the roof to maintain the smooth visual appearance of it. So you can see on the right-hand side that we ended up in some of these with lights stacked 3 high in order to get all the lights that were that were needed for the venue itself. In the Aquatics there were 421 kilowatt floodlights, again half of which were hot V-strike to give us our 2000 lux average. So there you see another view of the Aquatic Centre with the lighting pods, and also those panels with the lights that were mounted on the side of the building for the diving area. Now, in fact, they're only temporary. They're only there for the games. They come down after the games themselves. But they did have to be moved from that position to get rid of the flare for the TV cameras. If you look carefully, there's somebody just jumping off the diving board there, and again you see the brightness of the lighting, because obviously we're trying to light the diver as they go down, all the way down the path there in the air, and it's that compromise and balance between getting the light on the diver and avoiding lighting going in the eyes of the cameras, in the lens of the cameras. So when it came to commission the lighting, at that time there was no water in the pool, or there was water in part of the pool. So we devised a method which was some plastic plates that we attached to tape measures, and these were strung across the pool themselves, and these would be our aiming points. And then back up in the lighting pod, we had to attach our telescopic sight to the floodlight. But because of the tightness of the space and the way the floodlights were arranged, it was impossible to get your eye behind the aiming sight itself to see where the point was. So we attached on the back of the aiming sight, so I can just show you here, just here, is a webcam, and this was connected to a laptop. And so when we're up in the pool, this is the view that you get, the aiming sight attached to the floodlight on the left, and on the right-hand side, the screen of a laptop. So in the middle there, the black dot is in fact the laser pointer, which is the thing that you're trying to aim, and the little white dot just to the left is the plate on the pool that we were aiming at. Sometimes you have to be quite inventive when you're trying to work out how to take illuminance readings in free space. So when we're trying to check the lighting levels as a diver would come off the diving board, we strapped a light meter to a piece of wood, dropped it down over the edge of the 10-meter board, and we had someone at the edge of the pool with a set of binoculars taking readings off the light meter itself. It might sound a bit of a crazy way to do it, but it was a very practical solution, and it worked. When it came to taking readings, well, we had the bottom of the pool could come up to water level, which meant that we could quite easily place our marker cones on the surface and take readings. And again, this is another part of the whole legacy concept. The diving pool, for example, you can bring the floor up and you can turn it into a 1-meter pool that school children can come in and learn how to swim. So that was very much part of the idea of how we'd use that after the games itself. And for the main pool itself, where we couldn't get onto the surface to take readings, we just dropped somebody into an inflatable boat and pulled them around the pool taking readings. And so that's the final view of the Aquatic Centre. And following on from the use of the electronic control gear in the Velodrome, it was also installed over the diving area, again because that's an area where they particularly wanted to use the super slow motion cameras. After the games now are over, the Aquatic Centre is in the process of being converted back to this image, which is the architect's impression of the final build. So you see all the side rings are taken away, and we get a much higher daylight contribution with those big windows. So the need to use artificial lighting for any time during the day will almost be completely eliminated. So just before I finish, just a couple of comments about the park itself. The whole of the exterior lighting in the park was subject to an overall lighting strategy, which you see there on the right-hand side, which was to make sure that the lighting was coordinated. The whole of the Olympic project had an environmentalist as part of the team, so we had to make sure that, for example, where the waterways cut through the park, there was minimum lighting that fell onto these waterways, as it was a place where bats would fly around at night. Over here, bats are a protected species, so we have to make sure that the lighting doesn't interfere with their natural prey. So that was the outside of the park lighting. The village itself, the athletes' village, where all the athletes stayed, was on the park itself. It wasn't some distance away. I know many of the athletes said they really appreciated the fact that they could just come out of their accommodation and walk to the venue. But all of the accommodation was supplied with low energy LED lighting. So typically a 7-watt MR16 lamp in the downlighter was used, in all the athletes' accommodation, again to drive the overall energy cost down. And after the games, all of these flats are converted back into normal residential accommodation and will be sold off to a variety of people who want them, either sort of one-bedroom units, two or three-bedroom units. So again, the whole of the village will get rejuvenated, and it will become a community on the Olympic Park. And then finally, if you were watching the TV pictures, you might have seen the ArcelorMittal Orbit, which is in the UK the largest art construction. It's called a piece of art, and that again was lit up as a centrepiece in the Olympic Park. And after dark, the lighting would become animated and help to bring out the structure and the way that the metal lattice work just curves and bends around each other. So hopefully those of you that watched the Olympic Games were enthralled by what you saw on the television. In the end, I believe that London put on an exceptional Games, and ultimately most people saw that through the medium of broadcast, and if it hadn't have been for the lighting, then the broadcasters wouldn't have been possible. So hopefully you've found that interesting, a little run through some of the challenges and issues that we came up against when putting the broadcast lighting together for the London 2012 Olympics. So thank you very much for your attention, and I think if our moderator is there, if we have any questions, we can either answer them online or we'll answer them separately by mail. Thank you. Okay, I can see a few questions here in the question and answer. One question here: what kind of high frequency control gear did we use? In fact, when I say high frequency, it was actually 250 Hertz square wave control gear that gave you virtually a constant light output. It was something that was developed specifically for the project to drive the 1 kilowatt lamps. These lamps hadn't been designed originally to run on electronic control gear. So as part of the project, we had to do some life testing and customize some control gear that was originally designed for TV studio application to make it compatible with the 1 kilowatt lamp. Another question here: will the next Olympics be lit with LED-based solutions? I think that the answer to that is probably no, only because the next Olympics are 3.5 years away, and I suspect that they're probably already pretty much down the line with their lighting system. But I think that we could probably predict by the time we get to the next Olympics, there will be LED-based solutions for this type of application. Okay, just running down, there's a couple of thank yous, which I appreciate. There's one here: did we get any feedback from the broadcasters on the quality of the image, thanks to the lighting? I was with the broadcasters when they were in the Velodrome, trying out the new the new electronic control gear. And it's probably the first time there's been a complete indoor venue like that, that has been lit with this type of control gear. And they tried it at 300 frames a second, they tried it at 500 frames a second, and they tried it at 1,000 frames a second. And their comment back was, this is absolutely magic. They'd never had the ability to put any of their cameras anywhere in the venue and record super slow motion. In the past, what they tended to do was to take perhaps two specific areas, like the finish line and the last bend, and put additional tungsten lighting in there to give them the flicker-free lighting at those particular venues. And they really focused on those shots. But what they found in London was that they could record anything from anywhere. And their comments back were that they were really pleased with the lighting. Another question: what were the applications of LED lighting systems in the exterior lighting? Again, this is another example of the technology moving really fast. When the original external park lighting was planned, it was all going to be a white metal halide discharge lighting. As the games became closer, so LED exterior lighting solutions had gone from a possibility to a real practicality. And so before the final orders were made, the exterior lighting, particularly around the main venues, were switched to LED lighting. So in the final scheme, there was a mixture of some metal halide and LED lighting for the exterior lighting. Another question here: what was the added cost per fixture for the high-speed capable ballasts? I think that I can't give you an absolute figure, but it took the total package of the floodlights and the control gear up by a factor of 3. So if they would initially have been supplied with electromagnetic ballast, that was 1, then the whole package was 3. So it gives you some sort of order of magnitude of the extra cost for the electronic ballast. Clearly, you're trying to push 1 kilowatt through electronics, so it's going to be, significantly more costly to do that than to push it through a piece of copper iron. Just going through the other questions here. Were any of the spots used to light field solids? Were any of the spots used to light solid state light? No, there wasn't any of the sports fields lit with solid state lighting. It was only the external park lighting that was solid state. Okay, question from Paul Taylor. Do you think the games have created a lighting legacy that changes people's perceptions of lighting across other industries, especially the pixel system? I think the pixel system, and for those of you that aren't sure what that is, that was a system of individual lights that sat behind every seat. So there was something like 80,000 individual blocks of LED array. Each LED array had 9 pixels, each one of which was RGB. So in total in the stadium you had something like 2.5 million individual sources or addresses of light, and that was used to create animated effects within the spectator area. And I think for both the people who were watching it on TV and the people that were there, that system has completely raised the bar in terms of engaging with the spectators and bringing them into the event in a completely new way that we've not seen before. So I think that pixel system has shown the effect that lighting can have in making it much more of an event rather than just coming along to watch sport. It's all about entertainment, and it's all about broadcast and having fantastic pictures. Now, for certain, I understand the pixel system costs about £9 million, so it's not something that's going to be installed in every single stadium that's built. But I think there are ways in which lighting can be used now, and that's sort of shown the way to help engage with spectators. I could predict that perhaps when we eventually move to LED-based field of play lighting, there's another opportunity there for using the lighting, not just to light the players, but also to provide some form of animation and engage with the spectators. Who designed the pixel system, and whose idea was it to go off in that direction? I think it was something that Danny Boyle, who was the producer of the opening ceremony, very much wanted to have. Obviously, he needed to persuade somebody that they should pay for it, which was successful. In terms of who designed the system, off the top of my head, I haven't got the figure, but I do have that information. If anyone's really interested in what took place behind the opening ceremony, there's a very good article in the, I think, August edition of Lighting and Sound International that takes something like 30 pages to go right the way through all the different technical functions that were involved in putting the opening ceremony together. It's a very good read if you're interested in that sort of thing. Okay, I think we're getting to the end. I've got to the end of the list of questions here. So I think that if there's any more questions, we can handle them in the forums, and we'll be very happy to keep the discussion going there. So I think, having said that, again, thank you very much. I'd like to hand over to the moderator, who can sign it off. Thank you.
Hello, ladies and gentlemen. I'd like to thank you all for attending this wonderful webinar by Mike Simpson. If there are any questions left, we will be sending you a mail with the information for our LinkedIn community for you to keep on discussing this webinar topics, and a link to the YouTube version of this PowerPoint presentation of this webinar. Thank you, and have a great evening